Hello guys, welcome back to the new video series of system design. When it comes to building systems that actually work in the real world, three words decides your fate: latency, throughput and availability. Let's break them down in simple terms with the real world examples you won't forget. So what is latency? Latency is the time it takes for one request to complete, often measured in milliseconds. In a distributed system, we might be interested in the latency of a database returning the results of a query. If the database is a substantial source of latency, that could indicate we need to add an index or choose a different database model. So one real world example is when you are starting from your home to office, you are going to drive in a car. So how long it takes you to drive from your home to your office? Let's talk about what causes latency. First, the physical location. Transferring data through space will always take some time. If the location is far, it's going to take some time. Next, the complex computation. If your computation is complex, it's going to take longer to execute and increase latency. For example, a complex relational database query with lots of join will take longer than a simple lookup by ID. Next, congestion. When there are many message requests coming in at once and the system doesn't have the capacity to process them all, some requests will have to wait, then it increases the latency. Either these requests will be dropped and sent again, or they will sit in a queue waiting to be processed. The final one is too many nodes. If there are too many decision points in the pathway of a request, it will increase latency because each node along with the way adds time while processing the request and decides where to route it. So how we can improve latency? First, by making a better path by minimizing the number of nodes a request has to travel through. This can improve latencies. Next, choosing correct caching technique. Caching can dramatically improve latencies when it applied correctly. 3. The protocol choice. Certain protocols like HTTP2 intentionally reduce the amount of protocol overhead and can keep latency lower. So keep this in your mind and improve the latency in your application. Next, let's talk about throughput. Throughput is the amount of data that is successfully transmitted through a system in a certain amount of time. It is usually measured in a bits per second. So one of the real world example is how many cars are actually moving on that highway per minute. So what causes slow throughput? As we discussed in the latency, the congestion is one of the main issue here also. It's just like road traffic is caused by many people trying to get into the same destination. Low throughput in a software system can be caused by too many requests on the same network. Next, the protocol overhead. If the protocol used in a message transmission require handshakes and other back and forth communication patterns, the network can be overloaded because of this. The final one is latency. Since throughput is the amount of data transmitted over a set of period of time, high latency will reduce the amount of data that is transmitted overall. So what are the ways to improve the throughput? So we need to follow these three things. 1. Increasing the bandwidth, that is how many lanes the highway has, so that the cars can reach the destination very fast. Next, improving the latency. Third one is the protocol choice. Here also the TCP has a congestion avoidance feature that can help mitigate congestion that causes low throughput. So one of the critical part in this distributed system is the availability. Availability is the amount of time the system is able to respond. That is the ratio of uptime divided by uptime plus downtime. Availability is so important that infrastructure services like AWS and Google Cloud guarantee certain uptime in their service level agreements. The gold standard for high availability system is the 5 nines, that is 99.999% uptime. It's also important to think about when downtime happens. A business will notably affected if all downtime occurs at unfortunately high use moments like major shopping holidays like Black Friday, Cyber Monday, etc. Availability will be affected by hardware failures, software bugs, complex architectures, dependent service outages, request overloads, deployment issues. So we can improve the availability by clustering, that is running multiple instances of a part of a system. So if one node goes down, the rest can manage without it. Then having a proper backups. Data backups and replication ensures that if a data storage fails, like power outages at a data center that another copy can be accessed. Next, geographic redundancy, physically locating system in different parts of the world. Then automatic testing, deployments and rollbacks. So if we follow these things, then we can have an improved availability in our distributed system. Understand these concepts very well for your next system design interview. The system design interview will be in a broader perspective, and most of the questions around designing an application with good latency, throughput and high availability. So these are some of the sample questions like design XApp timeline and search, design Dropbox, design and retail application to handle millions of users. So that's it guys. Thanks for watching. If you like this video, please like and subscribe to my channel. We'll see you in the next video with another new topic. Until then, thank you. Bye bye.